Hello dear students. So last time we are studying the motion of connected bodies and we are done with that. Next topic is Atwood's machine. It's very important problem. Continuously questions are asked from this very topic. Okay, so what Atwood's machine or pulley system. Okay, the system is like this. This is a rigid support here and this is a pulley here, and then this is string. This string is connected to two different blocks, block A and block B of mass M1 and M2. Suppose this is block A and this one is block B. It's mass M1, it's mass M2, and it is mentioned that M2 is, let's suppose that M2 is greater than M1. Okay, then these are the assumptions. So assumption number one is that pulley is massless and frictionless, implies that the mass of this pulley is very small compared to the mass of these two individual blocks. Okay, and it's also frictionless, so it implies that there is no force of friction between this string, between this thread and this pulley. Right. Number two is the string is massless, inextensible and frictionless. So it implies that the string is massless. Again, its mass very negligibly small compared to the mass of the blocks. And number second is that it is inextensible, means that the length of the string remains constant. For example, from here to here, if it is 10 meters, it will always remain 10 meters. Okay, and it's also frictionless. So there is no force of friction between what and what, between the pulley and the string. Okay. The next is that the length of the string, so it in turn implies, now when the string is inextensible, when it's inextensible, so obviously the length of the string remains constant. And when these conditions are satisfied, that the pulley is frictionless, it's massless, and the string is also frictionless, so it in turn implies that it ensures that the tension of the string remains constant. Implies that if the tension at this point is suppose 10 Newton, then the tension at this point is also equal to 10 Newton. So suppose tension here that's equal to T, then the tension here will be also equal to T. Or at this point you can mention it here as well. So this is T, this is also T. Okay, taken a better. So simply the tension string remains constant, and it is because the pulley is massless and frictionless. And number next is that the string is also massless, inextensible and frictionless. It is because of these assumptions that we have this. Okay, so this follows from this assumption that the length of the string remains constant and the tension throughout the length of the string also remains constant. Now the question is like this: calculate A part acceleration of the blocks. So obviously if this mass is greater than this mass, this will go in the downward direction, this will accelerate in the downward direction, and this will accelerate in the upward direction. Right? So this accelerates downwards, so this accelerates upwards. Okay, so acceleration of the blocks we will have to calculate. And number next is that calculate the tension of the string, and number next is that calculate the force on the ceiling. Force on ceiling implies that what is the force exerted by its entire system on this ceiling, okay, on this rigid support. Taken a beta. So this is our question. Okay, and it's very important. We'll try to calculate the acceleration, we'll calculate the tension string, we'll calculate the force on the ceiling as well. Okay, by doing some genuine mathematics here, but at the end you will have to memorize some expressions in order to do the questions directly which are asked in the NEET or JEE math. Okay, so pause screen and write down. Okay, now we have to calculate this acceleration, tension, and the force on the ceiling. Right? Okay, so first of all we know that suppose this block goes in the downward direction, so obviously this block will go in the upward direction, and we will prove that the acceleration of this block and acceleration of this block are exactly same. If this block goes downwards with an acceleration of suppose 10 meter per second square, this block will go in the upward direction with an acceleration of 10 meter per second square. Taken a beta. Moreover, its velocity and its instantaneous velocity will be also same. If its velocity at any instant of time is suppose 5 meter per second, so the velocity of this block at that instant will be also 5 meter per second. Taken a beta. Okay, so let's try to prove that. Okay, so we'll assume that this is the origin here. Taken a beta. Now the distance of this block from this origin, suppose it is equal to x1. Suppose it's x1 from here to here. Then from here to here, suppose it's x2. This x2. And x1 and x2 are the distances of what? Of the blocks M1 and M2 from the origin. Okay, from this very point. Okay, so let's prove that the acceleration of this block and this block is exactly same but opposite in direction. Okay. Now length of the string remains constant, so L is equal to constant. Length of the string remains constant. Taken a bit. That means from here to here it's x1 and from here to here it's x2. So this in turn implies that x1 plus x2 is equal to constant. Suppose it is C is equal to constant. Right? X1 plus x2 is a constant. Taken a bit. Okay. Next what I will do is this. Now x1 and x2 they give the positions of the blocks of mass m1 and m2. What I will do is this: differentiate both sides with respect to time. I'll write it like this: differentiate both sides with respect to time. With respect to time. Okay. Now we know that upon differentiating the position with respect to time, so what it will be? It will be like this: dx1 divided by dt plus dx2 divided by dt is equal to d by dt of c, where c is a constant. ठीक है ना बेटा. Now differentiation of position with respect to time becomes velocity. So this is velocity v1 plus this here velocity v2, and difference of constant, you know that it is equal to 0. Okay, ठीक है ना बेटा. Now this equation in turn implies that v1 is equal to minus times v2. v1 is equal to minus times v2. So what this equation implies is this, that the velocity of this, instantaneous velocity of this, and instantaneous velocity of this will be exactly same but opposite in direction. Negative sign implies opposite direction. Opposite means that if this goes downwards, this will go upwards, or if this goes upwards, this will go downwards. ठीक है ना बेटा. Okay, now again differentiating it with respect to time. So here I will again write differentiate both sides with respect to time. Now here we have dv1 divided by dt plus dv2 divided by dt is equal to differentiation of 0 is again 0. ठीक है ना बेटा. Now we know that the differentiation of velocity with respect to time is what? That is acceleration. So acceleration a1 plus acceleration a2 will be equal to 0. This is another equation. ठीक है ना बेटा. Or this equation in turn implies that acceleration a1 is equal to minus times acceleration a2. So what does it mean? It means that the two blocks will have exactly same value of acceleration, but the direction will be opposite. Means that if this block suppose m2 is greater than m1, फिर ये नीचे जाएगा और ये ब्लॉक ऊपर जाएगा, but with the same acceleration. ठीक है ना बेटा. If for example m1 is greater than m2, then this will go down and this will go up, but with the same acceleration. Okay. So simply a1 equal to minus times a2 means that the magnitude of the acceleration of the two blocks is exactly same, but the direction will be opposite. If one block will go downwards, this block will go upwards. If this goes downwards, this will go upwards, and vice versa. Okay. So what we know till now is that the two blocks will have exactly same value of acceleration, and the two blocks will have exactly same value of instantaneous velocity, but the direction will be opposite. Fine. And it is because the length of the string remains constant. So this is the equation. Okay. So these two equations, this equation number, let's take it equation number first and equation number second. And this equation number first and equation number second follows from this equation that the length of the string remains constant. Fine. Okay. Pause screen, write it down. इसमें कुछ rocket science है नहीं, basic. We start from the basics and then we arrived at the two different equations. The instantaneous velocity of the two blocks will be exactly same. Acceleration of the two blocks will be exactly same, but in the opposite direction. Okay. So pause screen, write it down. अब ध्यान रखो बेटा. Now what we know is this acceleration of this and this is equal and opposite. Suppose that we assume that m2 is greater than m1. m2 is greater than m1, so obviously this will go down, this will go up with acceleration a and a. Their magnitude will be same, and we have proved this. Why this is a and this is also a. ठीक है ना बेटा? We have already proved this. Okay. The next is that we have to calculate what's the value of the a in terms of m1 and m2. Okay, and we have to calculate the value of t as well. Okay. So let's try it out. अब देखो बेटा कैसे कर लेंगे. Okay. Now this here block. Now how many forces are there on this block? Obviously only two forces. One is tension, the stick, and another is weight in the downward direction, m2g. And weight on this as well in the downward direction, that m1p. Weight is always downwards. Whether the block goes upwards or downwards, the weight is always downwards. Okay. So what we'll do is this: we'll construct a Freebody diagram for this, or write an equation for this, and write an equation for this as well. ठीक है ना बेटा? Okay. So here I will use what? NLM second, Newton's second law of motion. Newton's second law of motion. First of all, for this very block. Okay. So this goes upwards. So take that force positive just in the direction of acceleration, and take that force negative just opposite the direction of acceleration. So it will be like this: m1 multiplied by a, and we have it's like this. It's like this. M is equal to summation of all the external forces. Okay, so here for this mass it is m1 multiplied with its acceleration is a is equal to t minus m1 multiplied by g. This equation of first. ठीक है ना बेटा? Take this positive, take this negative. Now for this, take this positive, take this negative, because that force is to be taken positive, which is in the direction of acceleration, and that force is to be taken as negative, which is opposite the direction of acceleration. So for this, I'll write like this: m2 multiplied by a will be equal to m2g minus t. ठीक है ना बेटा? So that's equation number 2 for you. That's equation number 2. Okay. The next what I will do is this: I had to calculate the value of a and try to eliminate this t. So I will add the two equations. So here I will write down first plus second. I'll add the two equations. ठीक है ना बेटा? So here it will be m1 multiplied by a plus m2 multiplied by a is equal to, this t and t will cancel. So what we have is this, or we can write like this: t minus m1g plus m2 multiplied by g minus t. This t and t will cancel. So here I can write it like this: m1 plus m2 multiplied by a is equal to, here I will write down m2 minus m1 multiplied by g. So finally the acceleration, that is equal to m2 minus m1 multiplied by g divided by m1 plus m2. Now directly memorize this equation. Okay, ठीक है ना बेटा. So acceleration will be equal to this, or I can write it like this. अब देखो बेटा, it's equal to बड़ा मास माइनस छोटा मास divided by summation of mass multiplied by g. ठीक है ना बेटा. तो ऐसे याद रखो, बड़ा मास माइनस छोटा मास डिवाइड मल्टीप्लाइड बाय g divided by sum of masses. ऐसे याद रखो बेटा. ठीक है ना बेटा. बड़ा मास माइनस छोटा मास मल्टीप्लाइड बाय g divided by sum of the two masses. Okay, so m2 is greater than m1, so बड़ा मास minus bigger minus smaller divided by summation of the two mass multiplied by g. That's the way to calculate the acceleration in the Atwood's machine. ठीक है ना बेटा. Okay, now you can only memorize this equation and forget the remaining mathematics which we have done till now. Okay, that mathematics was only to satisfy your conscience, but at the end for the competitive exam you will have to memorize only this equation. Okay. Okay, now next is that we have to calculate the tension in the string. Okay, so suppose this equation number 3, for the acceleration. So here I will write down put equation number 3 either in the equation number first or in the equation number second, one and the same thing. ठीक है ना बेटा. So let's substitute in the equation number first. So in first, substitute it in the equation number first. So what we have is this. So here I will write down, it is like this. It is m1 multiplied by a. अब a के बदले क्या लिखेंगे बेटा. So it is m2 minus m1 multiplied by g divided by m1 plus m2. Okay, that's equal to t minus m1 multiplied by g. ठीक है ना बेटा. So I substitute simply its acceleration in the equation of first in order to calculate t. So let's try to calculate the value of t. Okay, so I will rub this off here and I will try to calculate what's the value of the t, tension in the string. ध्यान रखो बेटा. So let's try to calculate the value of the t, tension in the string. Okay, so from this very equation I will try to calculate the value of the t. So it will be like this. Go for the multiplication. So it will be m1 m2 minus m1 square multiplied by g divided by m1 plus m2 plus that m1g, this one. Okay, that will be equal tension in the string t. Right, now go for the cross multiplication. So it will be like this, m1 m2 g minus m1 square g plus m1 into m1 is m1 square multiplied by g, m1 into m2 is m1 m2 multiplied by g whole divided by m1 plus m2. That's equal tension in the string. ठीक है ना बेटा. So here we are. So this term and this term will cancel. This and this will add. So t will be equal to twice m1 m2 multiplied by g divided by m1 plus m2. So this is the tension string. ठीक है ना बेटा. So it is simply twice product divided by sum multiplied by g. I can write it like this: 2 product of masses divided by sum of masses multiplied by g. So this is the tension string. Okay, ठीक है ना बेटा. twice product divided by sum multiplied by g. यहाँ याद रखो बड़ा मास माइनस छोटा मास multiplied by g divided by, okay, multiplied by g. Then here tension twice product divided by sum multiplied by g. ठीक है ना बेटा. Okay, so you pause the screen and write it down. Okay, so here simply what I used is that NLM second, Newton's second law of motion. Then we have this equation number, this for m1, this equation is for m1, and this is for m2. Take care that the force which is in the direction of acceleration is to be taken positive, and the force that is opposite to the acceleration is to be taken negative. Then add these two equations in order to eliminate this t and t, or to calculate a. Okay, so we have added. Then by simple mathematics we have this. Now substitute this equation number 3 in the equation number first. So here a के बदले हमने क्या लिखा, m2 minus m1 divided by m1 plus m2 multiplied by g. That is this. Then bring this term here to calculate t. Then do some mathematics, some cross multiplication. Then finally we are here. This and this will cancel. This and this will add. So it will be like this: twice product divided by sum multiplied by g. That is the tension string. ठीक है ना बेटा. Now अब जो ये रिजल्ट और ये रिजल्ट है ना, इनको हाईलाइट कर लो और ये मेमोराइज कर लो. ठीक है ना बेटा. You can afford to forget all the mathematics what we have done, but you will have to memorize only two equations. Equation number 1 is this: acceleration is equal to बड़ा मास minus छोटा मास divided by summation of mass multiplied by g, and tension string will be twice product divided by sum multiplied by g. बस इतना याद रखना है for competitive exam. ठीक है ना बेटा. Okay, so pause the screen right now. Okay, so this Atwood's machine, this is the acceleration, बड़ा मास minus छोटा मास multiplied divided by sum of mass multiplied by g. T is equal to twice product divided by sum multiplied by g. ठीक है ना बेटा. Now the next question is that C part is that we have to calculate the force on the force on this on the ceiling. Okay, so let's try to calculate that. So this is a pulley here. Okay, in the downward direction there is one force, that is T, along this direction, and here is one more T, like this. Tension in the downward direction, which is pulling the pulley in the downward direction, so T and T. Okay, in the upward direction there is a force, suppose that F, which we have to calculate. Now this pulley, it's at rest. Simply this pulley is at rest. It's at rest, and its mass also equal to 0. So it's at rest and mass also equal to 0. So that simply implies that upward force must be equal to downward force. Because net force, when its mass is equal to 0 or it's at rest, so net force summation of all the forces must be equal to 0, which implies that upward force must be equal to downward force, T plus T. So that means F is equal to twice T. So this is the force on the ceiling, or I can write like this: F is equal to 2 multiplied by T. Now multiply this by 2, so it is equal to 4 times M1 M2 divided by M1 plus M2 multiplied by G. This is the force on the ceiling. Okay, so this is equation number first for you, this is equation number second for you, and this is equation number third for you. Okay, now on the same, let's do some simple examples like this. Suppose same example, M1 is given, that's equal to 4 kg, M2 is equal to 6 kg. So same question, you will have to calculate A, T, force on the ceiling is equal to what? This is what you have to calculate. So try it yourself. It's example number 1 for you on Atwood's machine. Example number 2. Let's take M1 equal to 3 kg. Let's take M2 equal to 7 kg. Question is again same, calculate acceleration, calculate tension string, calculate force on the ceiling is equal to what? Okay, now we can do directly without constructing Freebody diagram, without solving any mathematical equation. You can directly do it. Okay, like this. For example, you want to do part A. Okay, so you first of all write down all this. You write down all this and try this example number 1, example number 2, and then example number 3 yourself. Example number 3 is like this: M1 is equal, let's take it, suppose 2 kg. M2, let's take it 18 kg. Then calculate acceleration, tension, force on the ceiling. Try it yourself. Okay, so pause screen, write it down. ये try कर लो बेटा, ये 3 questions try कर लो. Pause screen, write it down. I'll show one example. Okay. अब ध्यान रखो बेटा. I'll show just one example. It's example of first, example of 2 and 3. You can do that yourself. Okay. So example of first is that you have to calculate acceleration. There is bada mass M2 minus M1 G M1 plus M2. ठीक है ना बेटा? अब ध्यान रखो बेटा. M2 is how much? There 6. It will be like this: 6 minus 4, 6 plus 4 multiplied by 10. So this here 2 and 10 is 20, divided by 10. Answer is 2 meters per second square. Okay, so the acceleration of one block, acceleration of another block will be also 2 meters per second square. But one will be moving upwards, bigger block downwards, smaller block upwards. Tension is string, twice product, 6 into 4, divided by sum 6 plus 4 multiplied by 10. Okay, so 6 plus 4 is 10. This and this will cancel. 6 4 is 24 into 2 is 48 Newton. ये रहा इसका आंसर. Then you want to calculate force on ceiling multiplied by 2. Simple. So that's 96 Newton. ठीक है ना बेटा? 96 Newton. Force on the ceiling will be equal to twice T. That's equal to 96 Newton. बस हो गया. In the same way you can do this. You can do orally. You can do it orally. Like this: बड़ा mass minus छोटा mass. So 7 minus 3 is 4 multiplied by 10 divided by 10. So that's 4 meters per second square answer. Okay, you can do this as well. Let's do one more example on Atwood's machine. ध्यान रखो बेटा. Suppose the example is like this. ध्यान रखो बेटा. Exactly same example, Atwood's machine. It is given to you that M1 is equal, let's take it 3 kg, and M2 बड़ा वाला mass, that is 7 kg. Suppose it is 7 kg. Okay, so let's do this example. Okay, then you will have to calculate this. Let's calculate all the parameters, all the possible parameters. A part acceleration, B part tension in string, C part force on ceiling. ठीक है ना बेटा? D part like this. Let's do some kinematics as well. D part, calculate instantaneous velocity. Instantaneous velocity of m2. Let's calculate m2. Instantaneous velocity of m2 at t equal to 2 seconds or t equal to 4 seconds. Okay, E part, calculate the distance covered or the displacement, one and the same thing, because the blocks are going along a straight line. Displacement of, suppose m1 at t equal to 3 seconds. Let's calculate these parameters. Okay, अब ध्यान रखो बेटा. So first of all let's calculate A. आराम से कर लेते हैं. Acceleration will be equal to बड़ा mass, that's m2 minus m1 divided by m1 plus m2 summation multiplied by g. ठीक है ना बेटा. अब ध्यान रखो. So it will be like this: 7 minus 3 plus 7 multiplied by 10. This and this will cancel. 7 minus 3 is 4 meter per second square. This is the acceleration, and it's the acceleration of m1 as well as acceleration of m2. But it will be, for m1 it will be upwards, for m2 it will be downwards. Simple. ठीक है ना बेटा. Now B part is that we will have to calculate tension necessity. So it will be twice product divided by sum multiplied by g. याद होना चाहिए. You have to memorize these equations. There is no other way. Okay. So 2 multiplied by 7 into 3, 7 plus 3, 10. This and this will cancel. So 7 3 is the 21 into 2 is 42 Newton. So this implies that force on the ceiling will be equal to 84 Newton. Simply double up this. ठीक है ना बेटा. So we have calculated B part as well as C part. C part is the force on the ceiling. That is this 84 Newton. Simply twice the tension strength. Okay. The next is that now C part is that we have to calculate what? Sorry, D part. D part is that we have to calculate instantaneous velocity. अब ध्यान रखो बेटा, जो ये acceleration है ना 4 meter per second square, that is a constant. It's not a function of time. It is a constant. When the acceleration will be constant, so we can use the equation of motion, because equations of motion are applicable only if acceleration is constant. So when it's constant, so let's try use the equation of motion. Okay, we have to calculate instantaneous velocity. We will use the equation v is equal to u plus at. V is equal to u plus at. In the initial state, what I have done is this: जो block m1 है ना, I have kept it, I have held it with the help of my hand. Okay, like this. It's at rest. Now I will release it. This block will go downward. This block will go upwards. When I will release it, initial velocity of the block is 0. Is key b 0? Is key b 0? Then this velocity will increase. Its velocity will also increase because both are accelerating, and accelerating means that their velocity must increase with the time. So what's the initial velocity? That is 0. Plus acceleration. How much is the acceleration? That's 4. After what time we have to calculate? After 4 seconds. So 4 into 4, so that's equal to 16 meters per second. Now the velocity of the m2 will be 16 meters per second. Velocity of m1 will be 16 meters per second. But this will be going downwards. This will be going upwards. Okay. Their instantaneous velocity is same only because they are connected by the same string. They are connected by the same string. If our string breaks, in that very situation, it's not necessary that the velocity of this and this will be same. Okay. So velocity is same only because they are connected by the same string. ठीक है ना बेटा? Okay, so we are done with the velocity. Then E part is that we have to calculate displacement or the distance. So again, we will use the equation of motion and this one. S is equal to ut plus 1 by 2 at square. Again, initial velocity is 0 plus 1 by 2 is how much we have calculated there. That comes out to be 4 multiplied by t square. After what time we have to calculate? After 3 seconds. So 3 ka square. So 2 1s are 2, 2 2s are 4, 3 square is 9, 9 2s are 18. So 18 meters is the answer. So that means this block will descend down in 18 meters and this block will descend up 18 meters. Exactly same. Okay. Suppose that if this covers more distance, this covers less, implies that the string gets elongated. But we already know that the string is inextensible. ठीक है ना बेटा? Okay. So very important problem. Very important. But what you have to memorize is one, this equation, and second, this equation. You do not memorize the equation for the F, because simply F will be equal to twice tension. जो टेंशन निकला डबल कर लो, वो बन जाएगा फोर्स ऑन द सीलिंग. ठीक है ना बेटा? Okay, so pause करिए, write it down. Very really important equation. Okay, we'll do an example next, which is asked in AMOS 2017, and that is based on this Atwood machine. Okay, so you pause it and write it down. So let's do one more illustration of the Atwood machine. Okay, so that the concepts will be crystal clear to you. Okay. So again same, and there's the Atwood machine. One block is 6 kg, another block is 4 kg. Obviously, बड़ा block नीचे जाएगा, छोटा block ऊपर जाएगा. If their mass are same, then obviously acceleration will be equal to 0. ठीक है ना बेटा? So this will go downwards with exactly same acceleration a. This will go upwards with exactly same acceleration a. ठीक है ना बेटा? their instantaneous velocity will be same, their instantaneous displacement will be also same. Okay, now we have to calculate what is the acceleration, what is the tension in the string which is same throughout, what is the force on the ceiling. Here you have to calculate what is the value. Obviously this is T, this is T, तो ये F कितना होगा, this is 12 because this is at rest, so ऊपर वाला force will be equal नीचे वाला force, so this must be equal this plus this, that is F is equal to twice T. Then we have to calculate instantaneous velocity at t equal 2 seconds, displacement at t equal 4 seconds. Fine. Okay. अब ध्यान रखो बेटा. Now concentrate on this. Okay. So let's first of all do A. Let's calculate A. A will be equal to बड़ा mass, that is 6, छोटा mass 4, summation of the 2, 6 plus 4 multiplied by G, that is 10. So that 6 minus 4 is 2 and 2, 10, then we cancel, so 2 meter per second square answer. ठीक है ना बेटा. B part is that you have to calculate tension, will be twice product 6 into 4 divided by 7, 6 plus 4 multiplied by 10. This and this will cancel. 6 4s are 24, 24 into 2 is 48 Newton. C part is that we have to calculate force on the ceiling, that will be twice T, so that's equal to 96 Newton. D part is that we have to calculate instantaneous velocity. Again, this acceleration is a constant. When it's constant, so we can use equation of motion. That means we can use this very equation, V is equal to U plus AT. ठीक है ना बेटा. Initial velocity कितना 0, so 0 plus acceleration कितना 2, time कितना 2, so 2 2s are 4 meter per second will be the velocity of the block 1 and block 2. One will be going downwards, this will be going upwards. Okay, so E part is that we have to calculate what? Displacement, and displacement using this equation, S is equal to 1 by 2 AT square, because U is equal to 0, so 1 by 2 AT square, so 1 by 2 A कितना निकला 2, T कितना है 4 square, so that's 2 and 2 will cancel, 4 square is 60 meters will be the answer. Okay, similar problem, no issues with that. Okay, repeat this problem. There's a home assignment for you. Repeat this problem. Let's take 1, M1 is equal to, let's take 2 kg and M2 is equal to 8 kg. Repeat this problem for this. This is home assignment for you. Let's do all these from A to E. Do all these 5 parts for using this M1 equal to 2 kg and substituting M2 equal to 8 kg. Okay. Pause screen. Write it down. Okay. Question is asked in MS 2070. Example number 6. 3 different Atwood machines are there. Blocks are given 2 kg, 2 kg, 3, 2, 1, 2. Okay, na beta? Now the question is that you are not supposed to calculate tension, but the question is arrange tension in string in the decreasing order. Arrange tension string in the decreasing order. So this is system first, system second, and system third. Okay. Now what you do is this. अगर आपको formula याद होगा, tension is equal to twice product divided with sum multiplied by G. Tension is equal to this. Is equal to twice product divided with sum multiplied by G. So this is the equation for the tension. ठीक है ना बेटा? Now this implies that the tension string is directly proportional to product, proportional to M1 M2 divided by M1 plus M2. ठीक है ना बेटा? अब देखो M1 M2 divided by M1 plus M2 for this is 2 into 2 divided by 2 plus 2. That's equal to 1 for this. 4 divided by 4, that's 1. For this it is 3 2s are 3 into 2 divided by 3 plus 2, which is equal to 6 by 5, and it is greater than 1. Or this is the product 1 into 2 divided by 1 plus 2. That's equal to what? 2 divided by 3. It is less than 1. This is equal to 1, greater than 1, less than 1. So that means this tension will be maximum. So it means that tension T2 is greater than tension T1 is greater than tension T3. So this is the decreasing order. Simple. ठीक है ना बेटा? It is directly proportional product divided by sum. So product here will be 2 2s are 4 divided by 2 plus 2 is 4. 4 by 4 is 1. 3 2s are 6 divided by 3 plus 2. Since numerator is greater than denominator, so it is greater than 1. Numerator is less than denominator, it means it's less than 1. That means this is greater than this is greater than this. So T2 is greater than there. Here it is tension T1, it is tension T2, and here it is tension T3. So T2 is greater than T1 is greater than T3. So this is the decreasing order. Simplest. लेकिन इसके लिए याद क्या होना चाहिए? ये इक्वेशन याद आपको होनी चाहिए. So that means for the Atwood machine you will have to memorize only 2 equations. Tension is equal to twice product divided by sum multiplied by G. Acceleration is बड़ा mass minus छोटा mass divided by बड़ा mass plus छोटा mass multiplied by G. ठीक है ना बेटा? And then force on the ceiling will be simply twice the tension. Okay. So pause screen, write it down. Okay, another question is like this: calculate acceleration of the blocks and calculate tension string, but this time there are 3 different blocks. Okay, so this 1, 2, 3. Okay, the potential string here, that is T1. So basically from here to here tension will be same. So here it is T1. So there are actually 2 strings. From here to here there is 1 string like this, and then from here to here there is another string. So tension in this string will be T2. So we are supposed to calculate T1 as well as T2. And first of all, let's calculate acceleration. Then from there on, we will calculate what is the tension in the string. Fine. Okay. So obviously this 5 plus 2 is 7, which is greater than 3, means that this whole system will go downwards with acceleration A. This will go upwards with an acceleration with the same acceleration that is equal to A. Fine. Okay. Ab dhyan rakho beta. Okay. Now let's construct a free body diagram. Okay. So I'll construct a combined free body diagram of all this. ठीक है ना बेटा. So इस दिशा में क्या force है? That's equal to 2g. And in the same direction there's another force, that is weight of this. So that will be the downward direction, that is 5g. In the downward direction there will be a force that is equal to 3g here. Okay, ठीक है ना बेटा. Now I'll construct a free body diagram for this entire system, and this entire system is like this. It's like this. Suppose here we have 5 plus 2 is 7, 7 plus 3 is 10, so its mass is 10 kg. Okay, free body diagram for the entire system. And suppose the acceleration is in downward direction with an acceleration of A. It goes in this direction with an acceleration of A. Okay. Now how many forces are there in the direction of acceleration? There are 2 forces, 2g and 5g. So in the downward direction along A there will be 7g. There will be 2g. I will write like this: 2g plus 5g, which is equal to 7g, or which is equal to 70 Newton. ठीक है ना बेटा? And then this force, this 3g, it is downwards, but it's opposed to A. So that means it is opposed to A. I'll show it here. So this here 3g. So this here free body diagram or the entire system, FBD for the entire system. ठीक है ना बेटा? When I will construct free body diagram for the entire system, the tension, the string, they form internal forces, and internal force are not responsible for acceleration. ठीक है ना बेटा? So I assume that this is a whole block, its acceleration is downwards. Now take that. So this force and this force in the direction of acceleration, I have shown that, and this force, this 3g, is opposite to this A, so it will be upwards. Okay, so that's equal to 30. ठीक है ना बेटा? Now simply use NLM second to calculate the value of A. So what's NLM second? That is mass equal to summation of all the forces. So mass is 10 multiplied by A is equal to summation of all the forces. Take those forces positive, which are in the direction of acceleration, those forces negative, which are opposite to it. So this 70 is in the direction of acceleration, take positive minus opposite, so we take negative. So this will be 10A is equal to 40. This and this will cancel. A will be equal to 4 meter per second square. So acceleration of all the 3 blocks is exactly same. Acceleration of this 4 meter per second square downwards, acceleration of this 4 meter per second square downwards, acceleration of this 4 meter per second square upwards. ठीक है ना बेटा? Okay. So simply what I have done is this: I construct the entire free body diagram, the entire system, and then I have shown all the external forces, not the internal forces. External force 2g, 5g, 3g in the direction of acceleration, in the direction of acceleration like this, opposite. So like this. Then use Newton's second law of motion to calculate the value of the A. ठीक है ना बेटा? As simple as that. Okay. So pause screen and write down. Okay. So we have calculated A, that is equal to 4 meter per second square. Now we have to calculate T1 and then T2. In order to calculate T1, I'll write here free body diagram. FBD for 3 kg block. For this block we'll construct free body diagram. So I say here, so this is 3 kg, only 3 kg. Now how many forces are there on this 3 kg? नीचे की दिशा में weight, that's 30. ऊपर की दिशा में tension, that's T1. ऊपर की दिशा में acceleration, which is equal to 4 meter per second square. ठीक है ना बेटा? Again use Newton's second law of motion, that is mass is equal to summation of all the forces, that is 3 4s are 12. Take that force positive, so this positive, this negative, so it will be T1 minus 30. 30 यहाँ आ जाएगा, so 12 plus 30 is 42. It will be T1, or T1 is equal to 42 Newton. ठीक है ना बेटा? Okay. Now next we have to calculate T2. In order to calculate T2, we'll construct free body diagram for 2g or 2 kilogram. Okay, we can construct diagram for this, construct free body diagram for this, but it will be a bit complicated. So better that for 2g, for 2 kilogram. So this is 2 kilogram. अब इस 2 किलोग्राम पर कितने फोर्सेस? 2 फोर्सेस. एक तो वेट नीचे की दिशा में, दैट इज 2g which is 20. दूसरा फोर्स ऊपर की दिशा में, दैट इज T2, ये वाला T2. it accelerates downwards or upwards? Downwards. With what acceleration? A, that is how much? 4. ठीक है ना बेटा? So again use Newton's second law of motion. Ma equal to summation of all the forces. Ma will be equal to 4s are 8. Summation of all forces, take this positive, take this negative in the direction of acceleration opposite. So 20 minus t2, t2 यहाँ आ जाएगा, will be 20 minus 8, 20 minus 8 कितना? 12 न्यूटन. आंसर क्या आ गया बेटा? 12 न्यूटन. So we have calculated t1, we have calculated t2, we have calculated a as well. Simple. है ना बेटा? Pause screen, write it down. For example number 8. Now there are 4 blocks this time. ठीक है ना बेटा? So how many strings are there? How many strings are there? There are 3 different strings. एक तो यहाँ से यहाँ. Support tension here, that is T1. दूसरी string यहाँ से यहाँ. Support tension is T2. तो यहाँ भी कितना tension होगा? T2. फिर यहाँ से यहाँ tension is T3. ठीक है ना बेटा? So number 1 is that we have to calculate acceleration. Number 2 is that we have to calculate tension the strings, and number 3 is that we have to calculate force on ceiling. That's like this. So obviously force on ceiling will be equal to T twice T2. तो T2 निकला, डबल कर लो, वो निकलेगा force on ceiling. As simple as that. ठीक है ना बेटा? So first of all we have to calculate what? Acceleration. We have to calculate acceleration. A part. In order to calculate acceleration, we'll construct what? Free body diagram of the whole system. Obviously 4 plus 3 is 7. 1 plus 2 is 3. 7 is greater than 3. This will go down. This will go up. So नीचे जाएगा. And every block will have same acceleration. Magnitude will be exactly same. ठीक है ना बेटा? Okay. अब ध्यान रखो बेटा. अब ध्यान रखो. So here I will construct the free body diagram of whole system. So here I will write down FBD of whole system. Free body diagram of whole system. So how much is mass? 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 1 is 10. तो ये 10. Let's assume acceleration is downwards. ठीक है ना बेटा? Let's assume acceleration is downwards. Now see which force is in the direction of acceleration. इसका weight नीचे 4g, इसका weight नीचे plus 3g 7g 70 न्यूटन. समझ में आया क्या बेटा? अब देखो बेटा 1g, जो ये 1g है ना और जो ये 2g है ना, they are opposed to acceleration. Now you have assumed acceleration downwards, so 1g and 2g ought to be shown in the upward direction. 1g, 2g, 3g, 30 न्यूटन. समझ में आया क्या बेटा? समझ में आया क्या? 4g, 3g in the direction of acceleration, 1g, 2g opposite A ऊपर. Newton's second law of motion, ma equal to summation of all the forces. Ma equal to summation of all the forces. 10A equal to, ये ले लो positive, ये ले लो negative. 70 minus 30, 40, 4 meter per second square. आंसर आ गया बेटा. We are done with part A. B part. Let's calculate tension in the string. Let's calculate tension in the string. So first of all let's calculate T1. So this here 1. इसके लिए फ्री बॉडी डायग्राम बना लो. इस 1 के लिए नीचे की दिशा में क्या है फोर्स? 1g वो हुआ 10 न्यूटन. ऊपर की दिशा में क्या है फोर्स? T1. ठीक है ना बेटा? एक्सेलरेशन नीचे ऊपर ऊपर. A again use ma equal to summation of all the forces. Ma equal to 1 into A. A कितना? 4 meter per second square. A is equal to 4, so 4 ones are 4. ये पॉजिटिव, ये नेगेटिव. T1 minus 10, 10 यहाँ आ जाएगा. 10 प्लस 4 कितना हुआ? 14 will be equal to T1. T1 कितना निकला? 14 न्यूटन. समझ में आया क्या? अब देखो बेटा, now we have to calculate T2. We have to calculate. We'll construct free body diagram for this. Or first of all, let's calculate T3. ठीक है ना बेटा? So let's calculate T3. So I had to construct what free body diagram? किसके लिए free body diagram? 4 के लिए. तो ये हुआ 4, ऊपर T3, नीचे 40, 4g that's 40, नीचे एक्सेलरेशन, ऊपर एक्सेलरेशन, नीचे एक्सेलरेशन. कितना एक्सेलरेशन? 4. माँ इक्वल टू अगेन सो 4 4 are 16, ये पॉजिटिव ये नेगेटिव 40 minus T3 will be equal to 40 minus 16 is 24 न्यूटन, तो ये निकला 24 न्यूटन, ठीक है ना बेटा। नाउ T2 you can calculate yourself। T2 ये फ्री बॉडी डायग्राम ऐसे मैं दिखाता हूँ, ध्यान रखो बेटा। सो दिस इज 2, तो ऊपर की दिशा में क्या है फोर्स T2, नीचे की दिशा में कितने फोर्स, एक तो T1 भी है और 2G भी है। 2G कितना 20, T1 कितना, T1 ऑलरेडी निकाला हमने कहीं पे 14, फिर इसी एक्सेलरेशन ऊपर नीचे, ऊपर कितनी एक्सेलरेशन 4, फिर माँ इक्वल समेशन ऑल फोर्स लगाओ, T2 निकालो, ठीक है ना बेटा। नीचे की दिशा में फोर्स 34 न्यूटन, then from there you can calculate value of T2 and then force on ceiling will be twice T2, you can do that as well, इसमें कोई रॉकेट साइंस है ही नहीं, ठीक है ना बेटा। Got it? Okay, I'll show one more example on this. Okay, so you pause screen, write it down.